Hello learners, today we are going to continue with our lessons from where we stopped. We are still under differential calculus and would like to talk briefly about derivative from first principles. Derivative by first principles refers to using algebra to find a general expression for the slope of a curve. It is also known as the delta method. The derivative is a measure of the instantaneous rate of change. Now look at the graphs here. As we look into it, you will realize that we have a point which is at A, and in this point we have two coordinates, x1 and y1. And when we go to the second point, we have x2 and then y2. Now, when we come to the x-axis, along the line, we have what we call the change in x, and then upwards, we have what we call the change in y. So let's look at the second graph. I will talk briefly about them. At this point too, we have a point here which has x value and a y value. But the first one is called the x1, and then the second one is called the y1. And then we go up along the line, then we have two coordinates. The first coordinate is x plus h. We call it the x2. And then we have f of x plus h, which is referred to as the y2. Also, when you come along the x-axis, we have x, we call it the change in x values, or x, and then we go up the y-axis, we call it the change in y. Now, so why are we trying to consider the two graphs here? If you look at the first graph, we're talking about the straight line graph, and we're talking about the slope of this graph, the direction that this line takes. So when we are using the 2 points on this graph, points A and B, to determine the gradient, we call it average gradient because it is the gradient of a straight line. And as you remember, the formula is y2 minus y1 all over x2 minus x1, which is also known as change in y divided by change in x. Now, when we come to the second graph, we are not really talking about a straight line graph here. We're talking about the curve which is lying on the Cartesian plane. This curve is a graph, and so we have to determine the gradient as well. But when we are now determining gradient at a point, gradient of a curve at a point, then we no longer call it average gradient, but we call it the instantaneous gradient. That is where we say the derivative. So we're talking about a derivative here. Now, so in this derivative, we need to have what we call the y2 minus y1. Now, when you come here, you realize that your y2 is f of x plus h. So you substitute it into this formula. Then we also go and look for our y1. Our y1 is f of x. So we substitute it there, just like we were working with the average gradient formula. Now let's go to the denominator. In the denominator, we will also look for the x2, and our x2 is x plus h, so we substitute it into the denominator. And then we look for our x1. So what is our x1 now? This is x. We come and substitute it into the formula. Remember, as you expand this bracket, x minus x gives you 0. Whatever is left is h only. But the numerator remains the same. So we come and substitute it into this. Now we have limit here. The word limit, this is the short form of limit. It is the extent to which you can go. It means you have a point at which you cannot go beyond that. Now, h tends to 0. Or this arrow, if you don't want to say tends, you can say approach. So h approaches 0. It does not necessarily mean h is equal to 0, but 0 is a limit which we can use. Now we have the first derivative here, or f prime of x. So f prime of x is telling us we are finding derivative, but not of a straight line, but of a curve. And that is why you see that whenever we are dealing with what we call first principles or derivative from first principles, we say f prime of x is equal to the limit of f of x plus h minus f of x all over h as h approaches 0 or h tends to 0. So this is what we talk about. Whenever we are working with derivative from first principles, do not forget the formula, because you are going to get 1 mark for the formula. So let us first look at this example. Find the first derivative from first principles if f of x is equal to 2x minus 1. So one thing you need to remember before even going on is that the question contains f of x. And if you remember the graph that we spoke about, f of x here is your y1. So we already have y1, which is 2x is equal to 2x minus 1 over 2. So now look at it. I need to find the y2. Now in the y2, if f of x is y1, then f of x plus h becomes the y2. So in the y2, remember in this bracket we are supposed to have x. So when we don't have x, then it means x plus h must be used to replace x in this column. We have 2x, but our x now changes to become x plus 2. What does it mean? Wherever there is x, you substitute x plus 2. So it becomes 2 into bracket x plus h minus 1 over 2. Let's move to the next step. So now we are just trying to expand this bracket by multiplying out with the 2. So 2 times x plus 2 times h minus 2. Now, these two steps we've just done prior to the formula are not the real core of our solution, but it gives you the most important stage at which you go. In marking, we are going to give you 1 mark for the formula. So when you get 1 mark, you move on, then you do what we call substitution. So you can substitute the whole of this, into the formula, or you can take the expanded form and substitute into the formula. So to make it easy, I have substituted the expanded form into the formula. Now, before we expand, I want to tell you a secret. In this step here, all you have to remember that anything or any term that does not have h should be eliminated. It should be at the back of your mind. Now look at it. What I'm saying is in the second step. Let us expand this bracket. Negative 1 times 2x will give us negative 2x. Negative 1 times negative half will give us plus 1 over 2. Now, if you look into this step now, you see that 2x does not have h. So you see, it has the inverse of its operation as negative 2x. So negative 2x plus 2 or 2x plus negative 2x will give us what? 0. I will say it again. 2x minus 2x will give us 0. Then we also have minus 1 over 2 plus 1 over 2. It will also give you 0. Can you see? All that will be left will be 2h. Like I said, at this stage, if anything that has h will continue to the next step. So 2h divided by h. As you can see, there is a common factor that can divide itself. H divided by h. So when we move on, h goes into itself once and goes into the other one once. So the result will be 2. So the first derivative is equal to 2. That is the solution for f of x is equal to 2x minus 1 over 2. Now let's look at the next example. In this example, we have f of x is equal to 2x squared minus 3x. So we have x here and we have x here. So it means that where in the y2, wherever we see x, we have to change it to x plus h. So now look at it. F of x plus h is equal to 2x squared, but now the x changes to x plus h. Now minus 3x, but also the x here changes to x plus h. So that is it. Then we take the next step and we see what happens. Now remember, this step here, this step is not the part of or the core aspect of the solution. The solution starts when we write the formula for derivative from first principles. Now, like I said, you can either use the expanded form of the substitution or you go straight away. So looking at this here, I decided to expand it first before substituting it into the first principles formula. So if you don't mind, let's go on. If you expand this, you are going to get this, which will be 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus bracket 2x squared minus 3x bracket close. Now, remember, the formula has f of x equal to 2x squared minus 3x. You must always put it in a bracket if you are subtracting from something which is on the right hand side. So we've done that. Without the bracket, you are going to have a confusion that will take place. Now, remember, I said anything that does not have h must go or must be eliminated. So if we expand this bracket, this whole thing will be negative 2x squared when we expand the bracket. So it will add to 2x squared. That becomes 0. So that one is gone. Negative 3x times negative 1 will give us positive 3x. Now, positive 3x plus negative 3x or negative 3x plus positive 3x will give us 0. Then what else? The rest of them have h. So we have to move to the next level. So we will take 4xh and take 2h squared and take minus 3h. So we have 4xh plus 2h squared minus 3h all divided by h in the formula. Now what happens? The common factor here is h, meaning whatever we can see that appears in all the three terms, we take it out. So h, so we take h out, and then we are left in the bracket with 4x plus 2h minus 3, all divided by h. What happens? We divide h by h. So when we divide h by h, we are going to be left with 4x plus 2h minus 3. Okay, so in this case, what happens? The denominator is 1. Therefore, we can do the substitution of h. We take 0, we put it where there is h. So 2 times 0 is 0. So the result will be 4x minus 3. So here is 4x minus 3. So that is the solution for the second question. We move to question 3. In this question 3, you can see we have x squared plus bx. Now, it explains that b is a real number. So remember that b can be any number, but at this stage you are not being asked to substitute any number for b. You keep it as it is. But what you need to take note of is to find your y2, f of x plus h. So in this regard, we have x plus h all squared plus b times x, and the x becomes x plus h, so b into x plus h. As usual, to get the first 1 mark, you write a formula. Don't forget, make sure that the derivative, the prime symbol between the f and the bracket where the x is, there must be that derivative symbol. Now, let us substitute. At this stage, you realize that I did not expand the bracket. I haven't even expanded the bracket. I just substituted it direct into it. So this tells you that as you go along, you master the tricks and you know how to do your substitution. So if you expand this bracket, if you expand these two brackets here, you are going to get x squared plus 2xh plus h squared plus bx plus bh minus x squared minus bx, all divided by h. Let us remember something. What did I say? Anything that does not have h attached to it must be eliminated. How? Let us look at it. We have x squared. There is no h. So let's look for another x squared. Yes, there is x squared here, and there is negative. So positive, negative will give us 0 there. Now, let's look at another thing. The rest of them, there is bx here. Wow. So this bx must also have the inverse operation, which is minus bx. That is also gone. Excellent. So now we can move to the next step where there is h. So all things that have h, let's see, the first one is 2xh. The next one is plus h squared. The next one is plus bh, good. Then all divided by h. As we reach this stage, what comes in your mind? Common factor. Now, the common factor is usually the h in the first principles here. So we divide h by h. What is left is 2x plus h plus b. Now, at this stage, the denominator of this function is 1. Therefore, we can substitute 0. And then where there is h, you put 0. Therefore, we have 2x plus b. Excellent. So that is a solution for that question. Here is another one. We have f of x is equal to negative x squared plus 2. So here we only have one term where there is x. So that is what we're going to focus on. Let us find y2, which is f of x plus h. So we have negative first, then we have x squared. So our x now changes to x plus h all squared plus 2. Then you can decide to expand the bracket immediately as I have done here, or you leave it for the next stage. Now let's start marking ourselves. The first thing is the formula. We got it. So now the expanded form of y2, like I always say, you don't have to substitute the expanded form if you like, or you can do. So now I have taken the expanded form and substitute into this formula minus. Remember, I said the whole of x minus x squared plus 2 must be put in a bracket. That is what has been done. Let's expand the bracket. But before we go to the next stage, what do you remember? We must see that negative x squared must have a positive x squared so that they can be nullified to be 0. Look at it. Look at it. We have negative times negative x squared will give us positive x squared. So that alone is 0. Then we have 2 times negative 1 will give us negative 2. Then 2 plus negative 2 will give us 0. So everything that has h will be minus 2xh minus h squared. Minus 2xh minus h squared. That comes here, and the denominator h follows. Now, what comes in your mind again? A common factor h. So what is left is h into bracket minus 2x minus h, all divided by h. But h divides h will give us 1. So now we have minus 2x minus h. But what happens here? The denominator is 1. Therefore, we substitute 0 for h in order to get minus 2x. So the result now is f prime of x is equal to negative 2x. Let's take a look at another example. This one is tricky. The reason is simple. It is a fraction. F of x is equal to 1 over x. So the denominator is x, therefore we have to write x plus h in the y2. Alright, so let's look at the formula. Here is our formula. So what we have to do here now is to substitute y2, which is negative 1 over x plus h, into the formula. Then we say minus y1. So minus y1 is negative 1 over x. But remember, you put a bracket. So if you expand that bracket, it will be negative 1 times negative 1 over x. So it will give us positive 1 over x. Now, there is always this, I have been telling you guys, that when this already is a fraction, the whole of this numerator is a fraction, And we still have another denominator, which is a fraction. Don't tell me you don't know that h can be written as a rational number, because h is a whole number. It can be divided by 1. So it means at the denominator here, h here can be seen to be h over 1. So the fractions are too many, as if we are building a story building. So we need to take this h over 1, here and find the inverse operation. So the inverse operation, or what we call the reciprocal, remember the term reciprocal, will become 1 over h. It's just like you are walking with your legs, and the next time you turn upside down and your head is walking and your legs are up. So that is what we call the reciprocal here. Now, so we can continue. Remember, you need to find what we call common denominator or least common denominator. In this case, the first denominator is x plus h. The second one is x. So since the two denominators are not the same, you multiply them. That is how we find the least common denominator. That is why you see x times x plus h will give us s into x plus h. I don't want to expand it now because it is simple to continue that way. Then from there, as you see here, after finding the common denominator, you cross multiply. So this negative 1 multiplies x will give us negative x. Then this 1 here multiplies x will give us x, and multiplies the h will give us h. That is why we have minus x plus h all over x into x plus h, all times the reciprocal of h over 1, which is 1 over h. Now, you know that minus x plus x is 0. So what is left is h. Now, we still bring the reciprocal of h here, which is 1 over h. And then what happens? You can decide to expand the bracket if you want. So we have expanded the bracket. X times x here will give us x squared. X times h here will give us xh. Now, if you look here, you see that we have h as a denominator here. But this h here, you see this h on top here, this numerator h, can divide this denominator h to become 1. So the numerator divides the denominator common, which is 1. So this 1 here will be left. This 1 times 1 is 1. And this 1 times x squared plus xh will be left. So what do? We substitute 0 for h, and 0 times x will give us 0. So what will be left is 1 out of x squared, or 1 divided by x squared. Now, as we come to the end of the lesson, we will also be urging you guys to go ahead and do a lot of work referring to past exam papers and answer the questions that follow them. Also, if you need online or offline tuition during this lockdown, you know many people are locked at home, they are not going anywhere, they are indoors. If you still want to carry on with your studies, we have online service and we can offer you. And I just want to say, well done guys for paying attention.